don't know, ethanol is C. I remember that you used to be able to condense these formulas, right? The first reactions of alcohol will be what? Like all other organic compounds. Combustion reactions. So all organic compounds will undergo combustion reactions. So they will all burn oxygen to produce carbon dioxide and water. So if you are in the exam and they ask for a reaction of a homologous series that you are not familiar with, you know that one will be combustion to produce carbon dioxide and water. Because it's a general for all organic compounds. They are molecules with high energy and they will all burn oxygen to give off the energy. Alright? Carbon dioxide and water product. Alright? But the water there is water vapor, water gas. Alright? So it is a C. So the condensed formula CH3 CH2OH. Can you follow this formula? Good, right? Plus oxygen gas. So you have to like probably give some heat to start the reaction, right? But in the book they don't have any condition. So carbon dioxide gas plus water vapor, right? Ethanol liquid at room temperature, right? Now, as I said before, when you balance in these equations, you balance the carbon first, then the hydrogen and the oxygen last, for it to be easy. So we need a 2 here, it's 2 carbon here, it's 3, 4, 5, 6 hydrogen. We're going to need a 3 over here, 3, 2, 6. This is 4. 4 and 3, 7, so we can just put 7 over 2. That's the first reactions of ethanol, okay? Second reaction is a reaction with sodium. Yes. 2 reaction with sodium. Sodium is Na, right? Sodium solid. So sodium is a group 1 metal, very reactive. Right? Sodium, potassium, they are very reactive metals. They will react with the alcohol to produce sodium ethoxide plus hydrogen. Alright? OH liquid plus Na solid to produce. So it's just basically the sodium replacing the hydrogen. Alright? So CH3 CH2O Na. So this is like a solid now. Salt in a sense. Right? Plus hydrogen. Yes. Third type of reaction is dehydration. So it's just the reverse of the hydration, right? So I remember that in alkenes you would add the water to produce the alcohol, but you could also have the reverse, which you convert the alcohol into the alkene, alright? But it's different in conditions, right? I will put the full structure for this so you can appreciate it a little bit. Concentrated sulfuric acid and high temperature, 170 degrees Celsius. Alright? So if we put the alcohol in concentrated sulfuric acid, heat, then we will produce the alkene plus water. C double bond C. What was it? It's heat. So this will be water vapor because it's high temperature, above the boiling point for water. This reaction. Right, so the water produced will be a gas. Again, condition you have to memorize. Alright? So as you can see, for the hydration, you had with a catalyst, high pressure, high temperature. In this case, it's concentrated sulfuric acid and the temperature not so high for the reverse reaction. Alright? Alright, so if you take this from the board, we move on into the fourth reaction. Combustion. That's it. 4. Oxidation, right? Right? So as you can see, it's a step by step. So alkenes could be oxidized to alcohol, and the alcohol can be further oxidized to acid. So it is an increase in oxidation from the alkenes to the alcohol to the carboxylic acid. Alright? So again, in organic chemistry, when you're talking about oxidation, you just need to indicate that, oh, this from the oxidizing agent, right? And then the conditions. This again is acidified AMNO4, or this can be acidified dichromate. That's the form, but double check this form here. Dichromate, but it's going to produce terminal R, so whichever condition, is the potassium permanganate or potassium dichromate, right? And the product here is the carboxylic acid. You're going to see, alright, so I'm just going to convert this to the full structure so you appreciate it better. Over here, C double bond O, O, A. Right? So it's like the oxygen would basically replace the 2 hydrogen in the cells. That's basically what's happening. And then 5. The reactions. Right, and this is going to produce an ester plus 1 saponification. Alright. So example that they want here is the ethanol, so C when they're writing it, they put the carboxylic acid first, alright? So let's keep it consistent, it might be an issue. metanoic acid. With ethanol, right? Alright, now the important thing you have to note here is that which molecule so we're going to produce an ester plus water, so we have to remove water here, right? You have to know that then OH in the water is going to come from the acid and the hydrogen come from the alcohol. That's why I put that mark here, right? So the OH remember that the acid part is first. C O, so this will break off and it's going to join to this oxygen. So this functional group here, the C-double-bond-OO, is the ester functional group.
See ester?
C-double-bond-O, bond-O
water.
plus H2O. Thank you. These are the conditions for this reaction. Concentrated sulfuric acid and heat. Right, so they didn't specify the let's not rush the ester. Alright? So let's just look at the reactions of carboxylic acid and then that's it for today. Clear? So you would know one of the reactions already, right? Well, two of the reactions you should know. Because I just show you one with the alcohol. And you know combustion. You see what I'm saying? So sometimes they overlap. Clear? So you should know combustion, all organic reaction, combustion produce carbon dioxide plus water. If alcohol react with acid, then the same thing as the carboxylic acid reacting with alcohol to produce the ester. Clear? So it can be reactive metal. They use calcium as the example here, but most likely magnesium can be used or potassium or sodium. Alright? So calcium solid. Alright? And it produces the salt plus hydrogen, right? So sodium ethanol plus hydrogen gas. Sorry, I put sodium, it's calcium we use, alright? But as I said before, the sodium salt could be used as well. So it's minus 1, so it's in the bracket. You know why we have it like this? Because the ethanol CH3COO is minus 1 and the calcium with the 2 plus. So if we exchange it, writing the formula of ionic compound. Right? So this would be like an ionic compound. It's actually a salt, right? With an organic base. Alright? So it produces salt plus hydrogen. That's the product here. The calcium ethanol. Metal oxide. Alright. These two examples here, they use potassium hydroxide and they use magnesium oxide, right? So sodium could work as well. So it's really a acid-base reaction, and that's a broad topic by itself. Or inorganic substance, but you can have organic acid as well there. So these are acid-base reactions. So a salt react with an acid. No, an acid react with a base starts to produce salt and water. That's the general principle. Alright? This is plus C, this is equal to liquid AQ. And these reactions, they don't really need any, they will really react in solution. So if you mix acid with a base in solution, they will react. You don't need any special condition. You just need to mix both of them in solution and the reaction will just naturally take place. Because a proton is always going to react with hydroxide to produce water. That's the ionic equation. Alright? And then finally, the carbonates as well, alright? Metal carbonates, or just say carbonates, or metal carbonates. Some that I use here is copper carbonate. And then a carbonate normally react with an acid to produce salt, carbon dioxide, and water. That's general principle for acid-base reactions again. Alright? So an acid react with a carbonate to produce salt, carbon dioxide, and water. So this salt here will be CH3COO bracket 2Cu. What's that in that solid? That's the insoluble. One takes aqueous. Plus CO2 plus water, liquid. Carbon dioxide is gas. Alright? We got 2 here to balance it. Alright? So in addition to those 3 reactions, then you would have like reaction with the alcohol to form the ester plus you have combustion reaction as well. Alright?